I want to thank everybody for coming out. Thank PyOhio for putting this all together. This is a really great event. I'm here to talk today about using Python as sort of a multi-tool for data science. There are a lot of packages that work together, and so we'll go through a lot of those and we'll see a lot of that kind of stuff and see how we can go from like raw data to all the way through to actually building sort of a toy machine learning classifier, and we'll go through all the steps of that in between. First off, though, my name is Derik Pell. I am an engineer at Emma. Quick plug, we're hiring remote devs. Hit me up if you're interested afterwards. I have a GitHub. That's me on Twitter. I actually am going to put all of this up on GitHub. And very recently, everything's going to be done in an Ipython notebook, and we'll get to go through all of that. Pretty recently, GitHub started rendering Ipython notebooks, so you don't even have to download it. You can just look at it if you wanted to. But you can also download it and play with the code. I'll show you what that means as we get further into this. Has anyone used Ipython Notebook before? Do you use them? Yes, awesome. I love the Ipython Notebook. I'm trying to convince everybody at my workplace to use it. I think I'm about the only one. So for those of you who don't know about the Ipython Notebook, if you've ever used Python, just like the REPL, like the command, the interpreter, Ipython is a much better interpreter because it's just a much better interpreter. Because you can, you know how when you like define a function inside Python and then you mess something up and you have to up arrow and then you have to go up line by line by line, Ipython lets you go up to the entire definition so you can, you know, change it there, and it's just really great. The notebook, one step beyond that, because you actually get to save off your state. So you can save off all the code that you've put in there. You can save off notes. You can then take this Ipython notebook and give it to other people, and then they have everything that you've done. So it's a really great resource for doing development and sharing it amongst people, either in the workplace or something like this, however you want to do it. You'll see a lot of the stuff everything I'm doing is going to be in the notebook. So you'll see some of the stuff you can do. You can run the code directly in the notebook. The notes are in Markdown, so you can put Markdown directly into the notebook. You can also put LaTeX. We'll see a little bit of that. So all in all, Ipython Notebook, highly recommend it as a tool for development, just in general. Now, some of the libraries that we're going to go through while we're in here. We're going to look at Pandas. Pandas, if you've ever used R, Pandas uses data frames a lot like R data frames. So that's going to be the main tool that we'll use to go in and take some very raw data and manipulate it very easily and figure out what we need, what we can keep, what we can throw away. Pandas is really great because it uses most of the Python syntax that you're used to. So you can do slices, and you know it functions almost exactly like any other sort of Python code. So it's very familiar. So if you don't have to learn R to get in and start manipulating data and getting things the way you want it. We'll also look quickly at Matplotlib, because when you're working with data, sooner or later you're going to have to show that to somebody, and they may not be able to look at code. They want to look at pretty pictures. Matplotlib is a really good graphing library. It ties directly into Pandas. Sorry. All these tools actually sort of work really closely together. They're all developed to link really well together. And so we'll see how you can go from Pandas and quickly plot some stuff if you want to plot directly out of Pandas, but then you can also call Matplotlib on your own and do your own plots, that type of thing. We'll look a little bit of that. NumPy is a library for scientific computing, and it uses its main data structure is an ND array or an n-dimensional array. So the Pandas data frames are two-dimensional arrays built on top of NumPy. So when you start using Pandas, you get all of the NumPy math features sort of built directly into your Pandas data frames, and so you don't have to jump out of one thing, and you can manipulate your data in Pandas and then start to like grab some numbers and do some things in it directly in the data frame if you need that. And then lastly, we'll look quickly at Scikit-Learn. That is a library for doing machine learning, and so we're going to look at a machine learning classifier at the very end of this. There's a whole suite of classifiers in Scikit-Learn. We're just going to look kind of quickly at one of them. So, kind of just to get started here, again, if you've never looked at Pandas, this is, you know, you can just go inside it. You can put data or put something inside your code inside your cell, like you see the two import statements, and then hit Shift-Enter, and it runs the code that's inside the cell. And then those imports are available to the entire page. So all the way down, we won't have to import anything else again. This all acts like one Python file, essentially. To show you kind of quickly, you can add a new cell pretty easily. And then once you start moving data in, you get great things like the tab complete. That, you know, so now with Pandas, we've imported it Pandas as PD. These are all the functions inside Pandas anytime we need that. So that's available to us. And then if you want to get rid of a cell, you're on it, you can delete it. And just so you know, I can't see it there very well, but I accidentally hit those scissor icon a lot instead of hitting the plus icon. It's really easy to pull the data frame back. I mean, to pull a cell back if you want to. So it's pretty forgiving as far as that goes. So that's the start of Pandas. I mean, the start of Ipython Notebook. We'll see more as we go along. I want to give you a little bit of background on the data that we're going to be looking at. In grad school a couple of years ago, I got really interested in voting, in congressional voting data, and I started looking at, trying to figure out whether or not we could predict voting based on the divisive nature of the current Congress. I realized that political science uses a lot of statistics, but they use very little like computer science. There's not a lot of machine learning, and there's not a lot of the kind of stuff we would do in data science applied to political science. So I started trying to do that. So the data that I'm looking at, I actually got from a website, and I pulled down the entire voting record of both houses of Congress since the beginning of the US. That's a lot of data, and it is like normally not really easy to deal with. Pandas made it much easier to be able to grab that data and pull it in. So what we're going to start looking at is actually the 113th Congress, which I think was 2013, 2014 voting records for both houses. And so that's what we're going to be going through as we kind of work our way toward trying to classify that data. So let's skip down here. So one of the things that Pandas makes really easy is reading in these files, right? So you can't see very well here, but this is actually a CSV file, right? So we're going to quickly just tell Pandas, read that CSV file into this variable here for us, the current legislators data frame. So this is the information on the current legislators. And this is really just amounts to almost metadata, really. It's names and, well, you'll see here. I set our max column. You can set most of the variables that, you know, the things you need to look at inside a data frame. By default, it only shows you 20 columns. We needed more than that, so we can set it to 50. More than we need, but still. And right there, we can actually start looking at, if I drop that size down a little bit, is that too small? Can you guys see that? We're good? Okay. Sorry? The back row, a little bigger is better. Okay? Yeah, that's better. All right, awesome. So anyway, yeah, this does exactly what you would expect something to do with a CSV. It has just broken it down into simple rows and columns, right? So we have the header file there that gives us what every column is, and then there's all the information. So if you want to go to Senator Brown's, I think he's got YouTube channel out here? Yeah, there's his YouTube ID and all that. He does YouTube and not Facebook, you know, because, you know, that's a little passe. But anyway, so this is all the information that you can, you can download this and import it. And we're not going to use a lot of this data. We'll get some more data further along. But just to show you how Dataframes, it uses a lot of the same type of syntax that you are familiar with. Here you're just taking a slice of the data frame. So we're only seeing the first 3 rows of the data frame there. So you could, you're used to taking slices of lists and things like that. Data frames work the exact same way. Also, if you just want to look at the last name, so you want to go in and pull out one particular column of that data frame. These are the last names. So Pandas actually has 2 major data types. It has a data frame, which is rows and columns. It also has a series, and a series is just the rows, and it's one single column. So anytime you go into a data frame and pull one column out, you start working with a series, and they have different functions on each one that you can do different things. You can see on the left-hand side over here, 1 through whatever we got there, that's the index. So every series has an index. Every data frame has an index also, but it pops out a little, it becomes a little more useful for us when we're dealing with series. So that's one complete column there. And you see when Ipython Notebook displays, it only displays part of the data because you don't want to see all, 500 and something rows. You could set it to do that if you wanted to, but it's a lot to take in. So when you start working with this data, Dataframes gives you a lot of power to actually go in and start pulling out data in very particular ways. So sometimes you want to pull out something other than just an entire row or an entire column, or you want to pull out something other than an entire column. So you can pull out a row, and it looks almost like doing a list comprehension, right? So what we're saying here is we want to take the current legislator's data frame, right? And I want you to give me a section of that data frame. The section that I want you to give me is take the current legislator's data frame, find the last name that's equal to chew. That's the section I want you to give me. So you can use the data frame within the data frame to define what parts you want to pull out. So here we run this code, and then we get Judy Chew, all of her information from the data frame that we imported. So this is the type of thing we'll do further along to really start picking out the particulars of the data that we want to see. So far we've looked at just sort of the metadata more or less, but eventually we're going to have to start getting to some numbers. So one of the things that we can do is start grabbing some counts of things that are inside this data frame. So here we can see that in that entire data frame, there are 301 Republicans, 236 Democrats, 3 independents, right? So what this has done is exactly what you think it would do. We have given it a particular column, and it has just gone through and done a count, of everybody of all the various parties. There are only 3 parties, so this is what you get, right? So, but it's really easy to start pulling some numbers out and start looking at some things. Now, again, when you go out and grab one column, you stop working with a data frame, you start working with a series, and a series mainly is just indexes and values. So if you need the values, you can just grab the values, and it pulls it back there as a list of values, right? It's actually an array of values, sorry. So technically, this is an ND array, one of the numpy array types. We can also look at the indices there. So those are the different indexes that we have. This is an index object, which is a pandas object. It has some manipulations we can do on it further along that are very specific to indexing. And then you can actually, the index and the value are linked together, so they're in the proper order. So if you take the first value and the first index, they always match up, right? So 301 Republicans in the list. So everything kind of keeps even for us, and we don't lose any data. This is all stuff that you would expect it to do, This is a well-behaved application so far. So we pulled in a CSV file, which is great. We can also pull in a JSON file, right? So the JSON file that we pulled in is the actual vote data. So we had looked at the voting members data. Now we're looking at the actual vote data. So Congress breaks the votes down in very unusual ways. It's the federal government, right? So one of the ways that this JSON file comes to us, or the way that this JSON file comes to us, is, let's switch over really quick. And yeah, I'll blow that up for you guys because that is not readable. Better? Can you guys, bigger? More bigger. All right, okay. So this is a standard JSON file, right? Everybody's seen something like this. We'll scroll back up here to the top. Well, anyway, so what we have is we have category, we have chamber, we have the Congress, we have all this, sort of metadata on the vote itself. And then those are all, you can see your sort of first layer keys in a JSON object. And underneath the last first layer key is, these are the I votes, because apparently we're still voting in the 17th century. So those are all the I votes, right? And then and we have inside the I votes, we have the voter name. They have a particular ID number, their party, and their state. And we go a little further down. Those are all the no votes, that type of thing. So this is what the JSON file looks like. But if you look over here, this is a little not quite right, because our rows, we have I, no, not voting, and present, but you don't really have information in there that looks like you would expect it to look. Like, what does failed mean, or 1/2 mean in an I row? Like, it doesn't really make sense. The reason is, when Pandas imports a JSON object, it has to have some point of reference. And so what it does is it takes all of those first layer keys and turns them into column headings. And then it takes any of the second layer keys and turns them into the rows. So we have, actually it takes the data inside that becomes like the second level keys, and that's the data that kind of gets pushed into the cells here for the data frame. So we have I there, but if you look all the way over here, these are the votes. So we have the I votes, and this is the information we had looked at inside there. It gets crushed in, and you can't really see it very well. And it's actually pretty hard, kind of hard to dig out of a data frame, because data frame is not really set up to have information in this particular way. So unfortunately, if you have a kind of a complex JSON object, you have to do a bit of manual manipulation to go in and actually grab what you need. So what I've done here is just kind of quickly, I've set up that same file. I'm opening it as a JSON file, reading the data in, and then you can see I'm creating a Pandas data frame, and then all I'm doing is I'm digging into the JSON data itself. I know that first layer, I want to look in the votes key, and I want to look in the I key, and then that gets me this sort of data frame, this yes data frame. These are the yes votes for this particular vote. Like, each JSON object represents one set of votes. So this is what we get, kind of digging manually into the JSON object. It's not that big of a deal, but that's where Pandas fails us a little bit. So we've got a brand new data frame that has all the yes votes, and those are all the yes votes on that particular vote. We can do the same thing with all the no votes, right? So we get all the people that voted against that. We're not seeing much partisanship so far. Like, everybody's kind of in sync. That is not a very good bill. What we can do is we want to start putting this information together, right? We don't want to just keep the yes and the no's separate. So I'm going to kind of recreate the data frame there. And Pandas has a concatenate, right? You would expect that to happen, like, because you want to be able to put information together. So their concatenate it's a Pandas function. It doesn't happen on a data frame. You actually pass it to, or in this case, a list of data frames. So here we're just passing it the two that we just created, the yes data frame and the no data frame. For those of you that may not have caught it earlier, you have 4 voting types: yes, no, present, and not voting. So right now we're just pulling out the yes and the no votes. And you can see right here, it has concatenated everything together for us. Sorry, another thing I did right here, I created a new column on our data frame. I created a vote column because what I had was a yes data frame and a no data frame. And when we put that together, we needed a way to be able to tell yes votes from no votes along the row, right? So I created a new vote column, and for inside the no data frame, I just set all the values of that new column into no. And then for the yes, I set it all to I. So that's how we ended up with a yes data frame that has the I votes and a no data frame that has the no votes. Concatenate them together. Don't run that code. That's bad. So we concatenate them together, and we can look here. You know, we have all these no votes, and then all of a sudden we have the yes votes, that sort of thing. So now we can. That's a very quick way that we can pull all of our data together and keep, the information that we need, keep from losing the information that we need. We just create it and drop it into a new column. So like I said, I wanted to look at all the data for a particular Congress. And each bill that comes up can have multiple votes. So we're talking about like a really large number of JSON objects that you would have to parse through to get all this information. We don't want to build that by hand. I wrote this incredibly ugly script to go through just to walk through the entire directory tree and put everything together and get us all the big data frame that we need. And it takes like 20 minutes to run. So get ready. Here we go. No, we're not going to do that. Luckily, what you can do is if you can pickle it. So if you guys aren't familiar with pickling, it's a way of serializing an object inside Python. And so the data frames have a toPickle function. So all I did was I grabbed everything, grabbed the whole big data frame, wrote it out to this particular pickle file, and I can then come back through and load it. Takes a moment for it to load. You notice the star right here? That's telling you that Ipython Notebook is doing some type of work. So now that it's gone to 16, which it keeps track of, the number of the cell that you're in, every cell increments, that type of thing. Every time you rerun a cell, it gets a new number. So if I reran this, it would come up to 17, that kind of thing. But in any case, yeah, so this is our file. What I brought in the bill number, the name of the voter in Congress, their ID, their party. Wanted to look at voting by, partisan voting, basically. So I brought in the sponsor party. So here we have the voter is a Democrat, but whoever sponsored the bill was a Republican. Their state, how they voted, and then the vote ID, because as I said earlier, each bill could have multiple votes on it. So we wanted to bring in the vote ID, perhaps to kind of split things out a little better. And you can look here, and if you follow the index all the way down, we're incrementing, but then we start to re-increment. And then we kind of re-increment again down there. That's because each data frame gets its own index, and then when it concatenates together, Pandas doesn't automatically re-index for us. We can re-index very easily. You can set not only can you call the index, you can actually set the index. So in this particular case, I just took the range from 1 to the length of the data frame plus 1 standard stuff. It doesn't really matter for our purposes what the index is. You could actually set the index. It doesn't have to be numeric. It can be alphabetic. We're going to see something along those lines later. That's really going to come in handy for us. And there's our data. There's all of our data right there, right? This huge amount of data that we're going to start going through. I think it's 316,000 rows. Nowhere near big data, but still pretty good size for us to look at. So with all this information, we want to start breaking some stuff down. We want to start looking at how this is, how it all lays out, right? So one of the things you can do inside a data frame is you can do a group by in the same way that you might do a pivot table. It's very similar to a pivot table. So what this is telling us, now you might not be able to see the difference here, but this part of it here, the group by, we're telling it take the entire data frame and just group it by the 3 parties that we know about. Then, outside of that, that returns a group by object. I want to take that group by object and I want to do a count of the votes in that object. And so that's what we get. 147,000 Democrats voted. Now this isn't yes, no yet, any of that stuff. That's just straight votes. That's how many votes were cast by Democrats in the 113th Congress, right? So what we can do is we can do a little more hierarchical group by, right? So we're now telling it, go through, group it by the bill, group it by the voter ID, and then group it by the party, and then give us the vote count of that. And so that's what we get back. On this particular bill, on this particular vote for that bill, 199 Democrats voted, 233 Republicans voted. What we have back here is a series. So the values are the numbers, they're the counts, but the index is everything else. So we have a hierarchical index. This entire thing is the index to this series. And it doesn't quite give us everything we want because we've got the number of Democrats that voted, but we don't really yet have how they voted. So we can throw that in. You can actually have vote as part of the group by, even though that's what we're taking account on. And then that gives us a series. I can line it up here with this really long, it rolled over. Oh, well, sorry. So this whole thing, again, is the index, and 6 is the count, 0 is the count. I'm going to drop this down for just a second, just to kind of get it in line there. Okay, so just to give you an idea, hopefully you guys can see this. I'll bump it back up in a moment. But now what we have is the bill, the vote, the sponsor, the party of the voter, and how they voted. So we can see three people voted no on that particular bill. Or 3 Democrats voted no, 6 Democrats didn't vote, 190 Democrats voted yes. Then it rolls down to Republicans, 37 voted no, that type of thing. So bump it back up so that everybody can see a little better. But essentially, that's what it's gotten us. We now have a series where we have all of the data on a vote as the index, and the value is actually the number of votes cast, you know, in yes, no, not voting per party, per vote, per bill. And then, see here again, that whole thing is now our index. So when you call the index like that, you get back a tuple that has all the index values in there. We want to be able to take that information and move it up so that it's column headings, right? Because we need to know, like the way it was spread out before, you know, we had yes, no votes as a column, but we need to be able to get those counts, and we need them to make sense. And the best way for them to make sense is for us to take all of these, this hierarchical index, all these various index values, and move them back up into column headings. And that's really easy to do. So a series has this unstack function. And when you unstack, that's exactly what it does. If you have a hierarchical series or a hierarchical index, it takes that index and just flips everything up to column headings. And then you get back a data frame. And so that's what we've got. And that's a little easier to look at. Now as you scroll across, all of these values are now individual cells. And so we can manipulate them individually as we did with the data frame earlier. But we also have this additional heading here, or this additional count here, that gives us, like we now know, it's going to roll down again. So the column, what it's done is it's cut off. We have yes, no, not voting, and present. Those last three columns have been shifted under visually, but if I knock this back down again, you can start to see that all of those columns are all the way across. So we have counts for all of those types of votes, yes, no, not voting, not present, that type of thing. So now we have a data frame that has all the numbers in it that we really need. And let me get down here and I'll bump it back up for you guys. Is that okay?
Quick question.
Yeah.
So the yay and yes and the no and nay, those are just inconsistencies from the raw data?
Yes, that's, again, our federal government. Because the Senate records its votes in one way and the House records its votes in another way. So we have yay and yes, nay and no, and we're going to take care of that here in a little bit. So I'll show you how to take that type of thing and bring it all into one column. We want all one yes column. But yeah, essentially that's what it is. It's the way our government does things. So anything else? Right? Okay. So one of the things, as you're looking at the numbers, you can see there are a lot of places where there are NAs or NANs, not in numbers, right? So what essentially has happened is it's gone through and it says, okay, I have yay as a column heading, but there are all these places where I don't have any information for yay because I actually have it as yes somewhere else. So it fills in with not a number because it doesn't have anything to put there. Since we're going to start doing some math on some things, we want to fill it in. You can do, data frames have a fill NA where you can fill it in with anything you want. We could fill it in with, anything. We're filling it in with zeros because that's better for mathematically for us. And now we've come back to a data frame that's all numbers for us, right? You have to do the in place to actually get it to, if you don't do the in place, it would return a new data frame, but we want to go ahead and make changes on this particular one. So that gets us a nice set of numbers to start playing around with. Now, like I said, one of the things you want to do when you have all these numbers is you're going to have to start visualizing it for somebody, right? You're going to have to give them pretty pictures. Matplotlib is the visualization tool, and it ties really well into our Pandas data frames here. You can see this line is Ipython Notebook magic for telling Matplotlib to show your graph in line. If you didn't, it would make the plot, but it would return a plot object that you would then do something with. This is telling Ipython Notebook, go ahead and show me the visualization that you've just put together. And there it is, right? So this is pretty straightforward. We've taken the first 10 rows of our data frame, and we've told it just to plot. And then we've given it the kind of plot that we want. In this case, it's a bar. And I went ahead and stacked it so that we could have all of our data kind of pushed together there. Pandas has then come through and sort of, we've given it very minimal information. It's kind of done what it thinks is best with that information, which in this case means taking the key and throwing it right in the middle of our picture. So it's a little difficult to deal with. But that's because we just sort of let it do its own thing. Here in a moment, we'll manually take control of the situation. But you can see we have our key there. We have all of our votes stacked on top of each other. And on the y-axis, we have our counts. But the x-axis is that sort of hierarchical series index that we had seen earlier. That's essentially what it's done. It's gone through and it's found all the numbers that it knows about, and it's plotted those because it knows how to plot numbers. So it's automatically any column that has numbers in it, it's tried to plot those out, and everything else becomes more or less an index that it's throwing along the x-axis, right? So, so this is where we're going to take and solve that problem you pointed out, which is we're going to take all of our all of our yays and yeses and kind of push them together, and we're going to create a new column. We're just going to create a yes column by taking all of the I votes and adding in all of the yay votes. So this is different than the concatenate we saw earlier. This is an actual math call, right? This is adding the values of those two columns together, right? And we're doing that for the nose. And then just to clean it up a little bit, we're going to drop some of the columns. We're going to drop the I and the yay and the nay and the no because we're adding them together. We don't need them individually anymore. You have to tell Pandas which axis to do things along. In this particular case, it defaults to doing along the rows. We want to tell it to do along the columns. So that's what the axis 1 is. Yes?
Quick question. Can you chain that add together? Like, let's say you had a third category that they said yuck.
Uh-huh.
You know, could you chain 3 of those together and it would add them, or do you have to do it pairwise?
Yeah. So the question was on the add on that first line there, where I'm adding I and yay, could I then chain another add on top of that and had like a yep add? That's a really good question. I don't know. I hadn't had to come across that. My guess is you probably could. Yeah, I mean because that's it. You know.
Returning a column, so.
Right. Yeah. So yeah, it should work that way. Okay. So we're going to revisualize that real fast. There we go. We've got it cleaned up a little bit. We still don't have much control over where everything's placed. So I just want to do a little more cleanup on the data, we're dropping the present and not voting because they're not doing much. And I'm going to add a sum column where I'm taking the sum of the rows, so it's going to go across and add all the yeses and all the nos, sum them up, putting them into a new sum column right there. And NP is numpy. Ooh, I forgot to import it. I imported it in the wrong place. Give me a second here. We are going to put that there. We're going to import numpy, which is the math functions, or one of the math libraries, and it has this standard deviation function. So what I'm doing is I'm taking the standard deviation of the sum column. So I'm creating a sum column, taking the standard deviation, filling it in a column, showing the first 6 rows of that. You can see here, that's the sum, that's the standard deviation. When we start to visualize it, it'll look a little better. Oh, wait, sorry. Those were the sums. That's the sum. That's the standard deviation, right? The standard deviation is the same for everything, but we needed to have it on each row because what we're going to do is come down here. We're going to import Matplotlib manually, and we're going to start graphing this data and have a little more control over it. The information that we're looking at is not really that interesting, so I really had to kind of fudge this a little bit to get us a graph that looks like anything. Let's just look at it real fast. And so what this is, all I've done is the x column, or I mean, sorry, the x-axis is the sum column. I've taken the sum column and just grabbed the values out of it. And then the y-axis is the square of those. It doesn't really tell us anything, but it gives us a nice little curve to look at, right? And then, and we can also set the labels, the square of votes and the sum of all votes. And that way you can see that if we go into Matplotlib directly, we have a little better manipulation manually of what we're getting, so we could go through and set this the way we want it. One of the interesting things for me, though, is we're not actually passing it y values. We're passing it a function, and we could do this for the x also. So Matplotlib will automatically go in, evaluate the function, and create the values for us. So we don't have to create it, put it in a list, give it a list to do. It does all of that for us behind the scenes. And I'll just show you this. This is interesting. One of the things you often do perhaps in data science is like you take all your data, but you want to know where it's going, like what kind of trends you're seeing in the data. You want to do a linear regression. And so here we've taken the stats library from SciPy, another Python library. We take the stats part of that. We can do a linear regression. We've set the x and the y the same as we had before. When you do a linear regression, these are all the values that you get back: the slope, the intercept, standard error, that type of thing. And you can actually plot those by taking NumPy's polyval function, which evaluates polynomial equations for you. Wish I had had that in college, right? So we're just passing the slope, the intercept, the x, and then it has, and then we're plotting that. We're plotting the plot we had before and this new linear regression, and there we go. We have, that's our original curve, and this is our linear regression line on it so that you can see, how things are progressing. So that's just, a little taste of the kind of manipulation you can do with data inside those libraries and get some, visualizations out of it and start doing some real statistical analysis of things. So the next thing we're going to look at real fast is machine learning. Machine learning, all the rage now, right? So, okay. The machine learning breaks down into usually one of two categories, either sorry, my mind went completely blank. Thank you, supervised and unsupervised. We're going to look at supervised learning, which essentially means we're going to give it a set of data that we already know how it breaks down. We're going to try and classify data. In this particular case, we're classifying it into yes or no votes. We're giving it a set of data. We already know how these people voted, right? So we're going to train a classifier, giving it information that we already know about, and we're going to give it a set of data and have it try to classify that data. And it's supervised because we already know the outcome. Unsupervised is we would give it data that we know almost nothing about and let it look for patterns. That's for another talk at another time. We're going to look at the k-nearest neighbor algorithm for classification. Essentially, what this does is it takes a point. If you think of it as in a Cartesian plane, it takes one point and looks for the k number of neighbors around there. You set k. In this case, it defaults to 5. So what it'll do is it takes a point that it doesn't know about, looks at the 5 closest neighbors that it already knows about, and then we'll give that unknown point something like the average of the values of its neighbors, or if they're all the same, it'll give it that value. Or there are a couple of different algorithms you can use to pick how it actually sets that value. But what we're doing is everything's close enough together, it's always going to get the same value as its neighbors, I mean. So here we are just kind of creating our final data frame. This is what it looks like. We're only looking at the party, the sponsor party, and the vote, right? We're back to the yays and nays. We're going to fix everything up because what we want is a bunch of numbers. So what I've done here is I've actually created this mapping where Republicans are 0 and Democrats are 1 and independents and nays and yays and all that. A data frame will take a map function, if you've ever done any type of functional programming, or if you've used map inside Python anywhere else, this is the same thing. Typically what map does is it takes your set of data and you map a function to that data and it returns you a new set in that way. In this case, you can either, for data frames mapping, you can either throw it a function or you can throw it like a dictionary. So I've created a dictionary, and that's how I went through and got all these, ones and zeros for everything. So in this particular case, 0 is Republican, 1 is yes. For party and sponsor, 0 is Republican, 1 is Democrat. For the actual vote, 0 is no and 1 is yes. We need to be able to pull the data apart, because when you train a classifier, you give it the data that you train on, and then separately you give it the classification that you know about. So here we're just taking our target is going to be the classifications that we know. We're taking our target, we're pulling out that last value, that last column from our current data frame, turning it into the target, grabbing the values. When it comes out in the series, it gets set, I believe, as a maybe a float value. I forgot exactly what it defaults to, but we need to set it to an integer. And then Ravel, when the series comes out, it comes out as, if you think of it sort of like a vertical array, right? So it's an array where like it's an array of arrays, and that inner array are each of the individual values. We need to kind of break that apart and turn it into almost like a list, right? So that's what the ravel function does. It takes that array of arrays and splits it apart, and you end up with just a simple array, a one-dimensional array instead of a 316,000 dimensional array that we would otherwise have. Again, training a classifier takes about 5 minutes. We don't really want to go through that, so we've been able to pickle it. In this particular case, we didn't use the Scikit-Learn doesn't have its own pickle function, so we just imported pickle, and then we are using the native Python pickling. I'll show you really quickly. This is just sort of how you set up the classifier. You pull in a k-nearest neighbors classifier. We're setting it to 4 neighbors. We're telling it to look at the distance between each neighbor, between the unknown value and its neighbors to figure out what the new value is going to be. Cross-validation is where we're going to take our entire 316,000 and we're going to break it down into 4 data sets. A training data and a training target, which are the known values, and then the test data and the test target, because you don't want to test against known trained data. You want to give it a separate set. And in this particular case, we're giving it the list of data, the data frame of data, the target, which was the array we just unraveled, and we want to tell it the test size is 10%. So leave off a random 10% of the data for testing. And we'll just import that real fast. And kind of quickly look at what we've got. Here we're just kind of looking at what we predicted. Yes?
Could you say what the data looks like? Is it just like a n by n array? Or?
Yeah, it really is just I've lost my mouse. What did I do with it? Oh, there we go. It's the data is just the first 2 columns. So like if you ignore the index there, so the data is just those 2 columns, and the target is that last column. We've just split it out into 2 different sets. And here we're just looking at what the classifier predicted a value would be and what the value actually is. And we're not looking really great there, just on that little 6 sample thing. You can actually, the classifiers actually have a scoring function right here. So you can go through, if you look right here in this commented out code, this is the score function. So you give it the test data and the test target, and it will go through and score how well you've done and print that out. We did 66%, so like we've trained this classifier and it is classifying 66% of our data properly. That's not really good. That's not very good at all. 80% or better is usually what you are looking for in a classifier, I think. So all in all, we didn't do really well, but that's probably because we didn't have a lot of really great data. We're only looking at like the party of the sponsor, the party of the voter, and how they voted. That's really limited data. Like we need some more information in there. I've put all the voting together. Like this is every bill that gets voted on. So this is gun control and let's rename a highway after like some war hero, right? So there's all this potentially partisan voting with all this stuff that nobody's going to vote against or nobody's going to vote for, however that goes. So what we really need at this point would be some sort of subject matter expert to come in here and start looking at these votes and go, yeah, this is what you really want to look at, and this is sort of noise to your classifier. So I have a little bit more on noise, but does anyone have any questions on this right now? Because if you have any questions, love to answer them. If not, I have a little bit more I can show. It's up to you guys. Yeah.
When you query your data set, can you use a wide content?
Can you use a what?
A wide content, partial.
Oh, yeah. Yeah, so when you query, you can use a wildcard when you query the data set. Again, that's a good question. I have not done that. I don't really know. I'll look at. I'll see if I can figure that out. I'm putting this up on my GitHub, and so I'll try and answer that question and then put it in the README or somewhere in there if you want to look on that and see. But I'm not sure off the top of my head if you can use a wildcard.
Next question.
Yeah. Yes.
I might have missed this, but does Scikit-Learn work with Pandas data frames?
Yeah, that's what we fed. It was a data frame.
Oh, okay.
So and sorry, I went through that a little too fast to really see. But so when we did the cross-validation, we gave it the data frame that holds the party sponsor and the party voter. And so that is the data frame. And then when we gave it the targets, the target is a series. So this is all Pandas stuff that the classifier is using behind the scenes. You could also feed it like a list or that type of thing if you wanted. But yeah.
Next question?
Another thing? All right. Thanks, everybody. Again, this is going to go up on my GitHub there if you want to check it out and run the code at some point.